In this video, I'm going to share with you two examples of solving for an unknown side for similar figures. Now these figures, these two rectangles, they are similar because they have the same shape. However, the lengths of the sides are different. You can see that in this rectangle, we've got two dimensions. We've got a base of 8 centimeters and a height of 4 centimeters. The smaller rectangle has a height of 2 centimeters and a base of an unknown number. We don't know what that number is. And by setting up two ratios that represent those sides, we can figure out what that x value is, because we know that those two shapes are similar or proportionate. Now there's a few ways that you could set up your proportion ratios. In one instance, we could set it up so that the 4 is on the top and the 8 is on the bottom. Or we can set it up with the base number, or the 8 on top and the 4 in the denominator position. We could also set it up where the 4 and the 2 is within one ratio and the 8 and the x is in the second ratio. I'm just going to choose one, and notice that I'm going to be consistent with my placement of the sides, and I'll show you here in a minute. So I'm going to put the height first on top with the base on the bottom of the same rectangle. And I'm going to set up another ratio following suit. So I want to have my height in the top position and then the base in the denominator position. Now I've set up proportionate ratios, and I'm going to solve for x. So remember, we're going to be doing cross multiplying. So 4 times x, and then 8 times 2. And then I want to go ahead and simplify that. So that becomes 4x. 8 times 2 is 16. And I want to solve by x by dividing by the number that x is being multiplied to on both sides. And those, of course, are going to cancel. And then 16 divided by 4 is 4. So x equals 4. 4 centimeters. And if we look back at the picture, if we say this is now 4 centimeters, you can kind of see that that's correct. I chose a particularly simple problem just so that you can see it. Notice that the height is half of the base, and in this case, in the smaller example, the height is half of the base. These two shapes or figures are similar or proportionate. Let's try one more example where we're working with right triangles, and I've thrown in some decimal numbers just to make it a little more interesting. Hopefully you can see those. Let me zoom out again. Okay, so in case you can't read it, the height of this smaller right triangle is 1 foot. This long side of the right triangle has a special name. It's called a hypotenuse. That is 1 75/100 of a foot, or 1.75. The height of the larger triangle is our unknown, and the hypotenuse of that triangle is 3.5 feet, or 3.5 feet. Again, we're going to set up proportionate ratios. And it doesn't matter if you put your larger number on top or your smaller number on top. Just to make it interesting, I'll go ahead and put the larger number on top because it was, it's a little different than the last one. You're going to come up with the same answer. Just be consistent when you make your second ratio. So in the top, I'm going to have 1.75 over 1. The hypotenuse over the height. Same here. Hypotenuse is 3.5 over our unknown. Now we're going to cross multiply 1.75 times x. That's going to give me 1.75 x. 1 times 3.5, well, that's the same thing as 3.5. And to isolate the x, I'm going to divide by the number that's multiplied to that x so that it gets canceled. And remember, if we divide by one side, we have to divide by the other side. So this is going to cancel, and I'm left with x. Now so I'm just going to go ahead and rewrite this, and I want to show you what we can do to simplify this, because this looks intimidating right now, but we can simplify this. Remember, when we have decimals in a fraction, we can eliminate those decimals by multiplying by a 10 or 100 or 1,000 or any other number that's based off of 10, a multiple. Okay, I'm going to multiply by 100 because my bottom number, my denominator, has 2 decimal places. So if I multiply by 100 on both sides, I'm going to get 350 over 175. And if you're not sure about this, please review another video that I made on writing ratios as fractions. And I talked about ratios using whole numbers, fractions, and decimals. I'm going to keep going. I need to figure out what x is. I'm not going to write it as this fraction. Now we could reduce. You could reduce it as a fraction, or you could go ahead and divide 350 by 175. And if you're not sure how many times 175 goes into 350, you could just start multiplying. Well, I think it might be 2. I'm going to go ahead and check. That's 10, 15, and 3. Hey, it goes in exactly. So, in this problem here, x equals 2. And again, knowing that this is 2 feet, this smaller triangle is half the size of the larger triangle. The height is half of the height of the larger one, and the hypotenuse is half the size of the larger hypotenuse.